Hey, Keely, good to see you there. Let me make sure Mubot's here. We are going to, Mubot needs to re-wake up. We got 20 people here, or I don't know how many we got. I sent out messages to everybody because we're only having online office hours today. And Keely says, can you explain how to do question 6 on chapter 5, part 2? 1, 2, 3, 4, 5, 6. Let's hop over and do it to the main screen. Got limited time, so let's get some work done. Okay, so here is the video. And Mubot is awake again now, so let me throw you some points. And 404. And this is Stat 201, Chapter 5, Homework 2, Question 6. Okay. The normal model has a mean and standard deviation of this. Now, for this part of this chapter, you need to use the applet. Do you have the applet open, Keely? Do you have the applet open? How are you doing on that? You should go to the applet right here, open it up. Mubot's pinned it, or he's got it posted. Get the applet open and try to put it side by side on the screen. That really helps to put it side by side. You might have to decrease fonts. But get the applet open so you can see what you're doing as you're creating it. And the important thing to know when working with the normal model is the normal model always has a what and a what. If anyone has any questions, we can do the full quiz, the full homework, anything. The normal model has a what and a what. I mean, you see it on the applet over there, like normal data. And data is unimodal symmetric. We talk about this. The mean and standard deviation, you got it. Write-ups for data analytics 2? Yeah, Adeline, we can do that next. You got it. Let me put that here. Question 4, we'll do question 4 next, and then we'll do the write-ups. Got this saved. So I'll put here question 4, and we'll do question 4 next, and then we'll do data analytics 2 write-up. Keep asking questions. We'll keep adding them to the screen. And thank you for all the interactions right here. Mubot giving you points. So with this, we need the mean and standard deviation to find the center of the curve, which is given to us, and the spread of the curve, which is given right here, which is, the standard deviation was 85,000. Now, what do you notice about these incomes instantaneously? I think I made oh, that's using this. What do you notice about these distributions? The incomes go what very quickly? Good to see you, David. The incomes go what very quickly? Look down there, which doesn't really make sense for incomes. Incomes go what very quickly, which doesn't make sense for income, which is not like how much money you have, it's your income. They go negative. So that really doesn't make sense. And so with this, probably the distribution of incomes are more like this, right? Does it make sense that income probably has a distribution that's more like this? And we could probably see this because what is higher than the what? If you look at the data, how can you see it probably has a right skew? We talked about this in class. The what is higher than the what? This right here, right there, yeah, that is this, is higher than the what, which indicates a very strong right skew. Yeah, is it this homework right here, Brian? Might be this homework. Might even go through the beginning of it. The mean is higher than the median. So we can still use the normal model, but it's probably a bad idea. It's just asking us, like, if the data was normal. If the data was normal, then where would be the top 4%? Now you have to go right here and do find x using percent. That's basically percent using p-value. And you could get the top 4% by doing 96, because the top 4% is the 96th percentile. You could also enter in 0.04 and get the top 4% with this. That's not the top 4, that's the bottom 4. Here's the top 4 right there. So the top 4% is the 96th percentile, and you can round it to the nearest dollar and get the answer right there. Yeah, the homework due today, that's what we're going to go over next here, probably start doing after a little bit more. I'll do a little bit more chapter 5. It's in the future and good work to get done. So why do we think this is going on? How confident are you? I'd be not confident due to the extreme skew nature of the data. And it's probably because the data, it's only possibly confident if the data is unimodal symmetric without obvious outliers, which it probably is not. This data is probably extremely skewed. Since the mean is much higher, the median is much less than the mean, and standard deviation and mean are very close, it indicates a very right skew. Remember we said the mean is being pulled in the direction of the skew. So pretty good question right there, using the normal applet and having us find the top 4%. I'm having a hard time picking data for the Kaggle. Okay. Kaggle data for Mosaic. Thank you, Dave, right there. We'll do that. We've got it on the list right now. I've got 2 things before that. Let's do, I think it's question number 4. We're going to keep rocking and rolling right here. And Scott, put some questions for quiz 3. And I got some quiz 3 here. Let me know which ones you're stuck on. We'll work on those too. And so just drop whatever you want in the chat. I think someone said number 4. So here we go, number 4, and let's mark the time for it and just keep asking questions. It's part 1. Part 1 is a different concept using the empirical rule. So I was like, I've got 10 minutes. What do I do with those 10 minutes? And I chose to give you the applet. There's all people get stuck on. Here is question number 4 on the homework, part 2. The accompanying histogram shows the ACT scores for a bunch of schools. The data points fall 1 standard deviation below the mean. Compare these parts. Now here's something really great. If you're in 320, which Dave is, these are called normal probability plots. Now, when you look at a normal probability plot, and this is for 201 right now, but also 320 does it, you are wondering if the data is normal. And the more it follows the line, the more normal it is. So if I run right here, analyze distribution, and I do it for, let's say, average temperature, notice how it has a slight skew to it to the left side, and the mean is lower than the median. You can go right here to normal quantile plot, and the more it follows this red line down the center, good to see you, Darius, the more normal it is. So the most normal quantile plot you would ever see is one that perfectly follows this line. Does that make sense? Yep, we're going to do some homework coming up here next, Olivia. You got it. So if you have a normal quantile plot, known as a normal probability plot, the more normal it is, the more it follows the what? This plot right here is telling you if your data down here is normal, and the more it follows the what? 4-letter word starts with an L. The more it follows the what? The more it follows the what, the more normal it is. The more it follows the what, which is a 320 concept too. The more it follows the what? The more it follows the line. Great answer, Darius. You got it. So let's go look at their questions and see how this applies. So for their question, which we don't need the applet for this one, I think, they're wondering, give 2 reasons a normal model is not appropriate for this data. Look at this down here. Does that look normal? That's got a second little smaller mode, right? So what you would need to know is it's a little bimodal with that low and high mode. If a normal model is appropriate, about 68% would fall within 1 standard deviation. You could check this with the applet right here by going within 1 standard deviation. Let's put the normal curve on here, the standard normal. And within 1 standard deviation is about 68% of the data. That's a fact that I'll tell you later on. 68, 95, 99.7. So 95% of the data would be within how many standard deviations? Did you hear it? 68, 95, 99.7. 68 is the percent of data within plus or minus 1 standard deviation. If the curve is normal, we would expect 95% of the data within plus or minus how many standard deviations? We'd expect 95% of the data within not 1 standard deviation, but how many standard deviations? We'd expect 95% of the data within how many standard deviations? Answers on the screen and visually. Within how many? Does anyone know? No one knows. Surely someone can see it. It's on the screen. Within how many standard deviations? We expect 95% of the middle of the data. 95% of the data, according to the normal model, within plus or minus 2. Great job, Dave, right there. So this says 1, so it's wrong. It says 1, so it's wrong. Don't worry, 4, great answers, 500 points right there. 2 is the correct answer. That is a wrong answer. 68 would be within 1 standard deviation if it's normal. Now, what we have going on with this is we're trying to look at, is this normal or is this normal? This is where they remove the low outliers. Did it become more normal by removing the low outliers? Did it become more normal by removing the low outliers? Remember I said the more it follows the line, the more normal it is? So they removed the low outliers, and here's the new one. Wow. Did it become more normal, yes or no? Remember, the more linear it is, the more it follows a line, the more normal it is. So did it become more normal when we removed the low outliers, yes or no? What do you think? Don't worry about being wrong. There's points for every answer. Does this look more linear than here? Does it look to follow a line better? Yes, you're right, Darius. It became more normal. So what would this indicate to us? The shape is more approximately normal than with all the schools. When we removed the low outliers, it became more normal. That's the full question. What kind of graphic? Last question right here. Nice and easy one. We've almost done the full homework if you came to class. What kind of graphic can we make to determine if a distribution is approximately normal? it would tell us the probability something is normal, A, B, C, D, or E. We'll just finish off the rest of this homework really quick, then we'll do data analytics. So what graphic do we use to analyze the normality of data? We were just talking about it a moment ago. We were just looking at it a moment ago. There's a lot of names for it. I called it a normal quantile plot. So what sounds most like that? A, B, C, D, or E? Which sounds most like that? And bar charts are for categorical, so we can't use that. Frequency tables for categorical. And it'd be a normal probability plot. Remember, box plots don't really show shape really well. Good thing they didn't put histogram, because histograms they're not horrible, but they show shape well, but normal probability plot's the best. This one, can we do it really quickly? Oh, is this data normal? Is that data normal? Is that data normal? We just did the full quiz. If you do our homework, I think we did question 6. Is that no? Because it doesn't follow the law. It's not normal. What way is it skewed? It's skewed to the right. Because it's the way it's pushed. The reason is the easy way to tell skewness when looking at this is the direction by which it's pushed. If it's pushed this way, it's right skew. If you notice like a push in on it that way, that's how to tell the skewness. Like it'll have a divot. Like instead of it being straight, it divots in towards, like it's like someone pushed in towards the right. And then a left skew one will have data that looks like that, where it's pushed into the left side. Like which directionality are we pushing in on it? That's the easiest way to tell skewness on that graphic. I think we've done all of them actually. Check out this video. This video has all, and class has all for that. Let's talk about some data analytics 2 right here. So we're switching topics. 320 will be coming up after this, and then we'll do the homework and the quiz. So this is the data analytics 2 write-up. Taking a note right here. How's everyone doing today? Did I turn off the music? I did. How is everyone doing today? Doing well? Stat 201, data analytics 2, the write-up. Okay. Let's do the categorical first. Doing great, awesome. So one thing I want to stress, doing great, like Olivia right there, is whenever you're doing your data analytics assignments, always look at the what to see if you've done them right. Whenever you're doing a data analytics assignment, you need to look at the what. Am I doing it right? You need to go and look at the what. What do you need to go and look at to be like, am I doing this right? Am I doing this right? Have I done this correctly? What should you go look at? You could look at the video, the directions, the rubric. The rubric is the #1 way to know if you're doing things correctly. Did you put your name and all the information at the top? All you do is just take this information right here, drop it in, fill it out. So make sure you look at the rubric, because the graders are literally going to be clicking these buttons here. So you'll know you've gotten your points if you do things like take a random sample, include a bar chart screenshot, and then it tells you what the points are if you've done it correctly. Bar chart write-up, pie chart screenshot, make sure you're not doing phone pictures or have extra parts of the screen, pie chart write-up, histogram screenshot, histogram write-up, and correct center and spread are chosen. So always double check the rubric. I'm pretty good about getting hundreds on these. One time I missed one little thing, little tiny thing. So double check all the things that the assignment says. With that said, let's go take a look at some data. So we're going to open up Pokemon data, because everyone loves Pokemon. And the first part of this is going to have you make categorical displays of data. So what are we having you make for the first part of this assignment for categorical displays of data? What are we having you make for categorical displays of data? What are you making? For categorical displays of data, what are you going to make? It's up there, way up there. What are you going to make for categorical displays of data? No ideas? It's on the assignment too. To display categorical data, we could use this, or we could use this, or we could use this. It's all the way at the top, where my hand disappears. How do we visualize categorical data? Just univariate one at a time. Throw some mute points. What are people thinking? I feel like chat's moving. People could be answering. Sometimes the chat lags out. Ooh, no one knows? The visualization of a categorical variable is done how? Make a what? Answers are on the screen. I'm going to double check, make sure chat is going. Bar pie. Oh, no worries, Darius. Darius, I'm throwing you 1,000 points, Darius. I appreciate that answer. I appreciate this. I'm also making this for people in the future who watch this, so I got to remember that too. That someone's gonna be like, I know it, Brian. It's a bar chart, a pie chart, a frequency table, a Pareto plot, which is a bar put in order. It's a ring chart, which no one makes, or a donut chart, which is just another name for a ring chart. Exactly. So I want people to utilize this, and that's my point. So in the future people, thank you so much for being here. We love you. You're awesome. So thank you for using this video right here. And let's go here and make a pie chart. To make a pie chart, you need a categorical variable, which means you need one of the ones with red or green technically, but we're going to use a red one right here. Yeah, associate function. Got that right there, Aditya. We'll do that here coming up. So let me put that right here. Associate function. We'll do that with the other 321. Associate function for 320. Okay, got it on the list. Thank you for being here. So when you're in the graph builder function, you want to take a categorical variable to make a pie chart. We're going to do legendary and drop it here in the center. And guess what? You're going to click pie chart. And then go ahead and go to labels and label by, I'm going to do percent, and then click and see, yours might say percent or count. Usually we're fine on either. And then click done. This is done now. Now screenshot it. Get a nice, good screenshot of this right there. Look at that. Legendary screenshot. Boom. This screenshot, you drop into your Word document and explain it. This one's very easy to explain. What do you think I'd write about this? When analyzing legendary Pokemon, we're analyzing whether it's true or false that the Pokemon is legendary. True being that the Pokemon is a legendary Pokemon, and false being that it's not a legendary Pokemon. In the data, we observe that 91.9% of the Pokemon are not legendary. False. We also observe that 8.1% of the data, 8.1% of the Pokemon are legendary, which was the true level. That's all there is to say on this. And be careful, it might say in ascending or descending order. Check the assignment. It might say explain your bars in ascending or descending order. That always catches me. Does it say ascending? Descending order? Describe. Might not say it this year, but that always catches me off guard. All you're going to do is just talk about the categories and what is most common, least common. Well, what about if we make a bar chart? Bar charts also have frequencies or percentages, and this can be done via analyze fit y by x. There's other ways to do it, analyze distribution. Under analyze distribution, you're simply going to double click the variable of interest, which is legendary, and then click OK. Once you click OK, the red arrows have your options. Click here under distributions. You will use the diamond data set. That is correct, David. I do different data sets because that way I'm doing something slightly different. Same work though. And good work, David. Good question too. So then we go to stack right here. Then we go to the second red arrow, which has more options, different type of options. Histogram options, count axis. Make sure to click this. Count axis appears. You can slow or pause the video if you want. Make it nice and big. I like to change the color. Histogram options, histogram color, light purple. And there we go. Pretty good looking data. What does this all mean? Well, we're going to take a screenshot of it. And guess we could include legendary up here. Just depends on what you want. That's good enough. Don't get extra stuff. Don't get that. You want to make sure your screenshot's nice. You can get a little extra and then crop it, but if you do, crop out that extra. And there is our good screenshot right there. So what do we have right here? It's the same sort of information, but we do have a frequency table and a relative frequency table. Remember, the relative frequency table shows you percent, where the frequency table shows you the counts of the observations. So, and does it say the numbers need to appear over the bars? This could be one error. Pause, and I'm like, did I do this? For the bar chart, show it above the bars. So you have to go here, and I think that's in my video. Check one thing. To show the numbers above the bars, do show counts above bars. Show counts above bars. It's quite redundant. It's quite redundant. Show counts above bars. And I better have done that in the video that I posted here. Yeah, I did. Of course I did. There we go. So there is showing the counts above the bars. As you can see right there, the video also walks through this. That is the frequency of the observations right there. Totally different data set. And showing the counts of all the observations. From here, you pretty much just talk about it. You just explain what is most common to least common within these groups. Did I just do the full assignment back then? I don't even know. What am I doing to a full assignment? Most people were lucky. And so with this, a bar chart is a visualization of a categorical variable showing you the frequencies or relative frequencies of each group. We can see there were 735 Pokemon that were not legendary, 65 Pokemon that were legendary out of the total 800 that were sampled. And once again, you need to take your random sample when doing this assignment. Make sure to do that, do the assignment in order from start to finish. We're just talking about how to interpret categorical data. So what is the last part of this assignment? It's interpreting not categorical, but what kind of data? The last part of this assignment is not interpreting categorical data. It's interpreting what data? And we're doing univariate, meaning one variable. The last part of this assignment is not categorical. The last part of this assignment is interpreting quantitative data, actual numbers. Quantitative, Darius, you got it. So what are the three things we interpret when interpreting quantitative data? This actually goes to today's lecture. That's last time we talked. What three things? Great job, Darius, right there. Also, and Brooke. What are the three things we interpret when interpreting quantitative data? What do we interpret? Shape, center, spread, right? Shape, center, spread are the interpretations, and you have to start with shape because shape determines center spread. Because the distribution is so skewed here, the proper spread is IQR and the proper center is median. If the data had looked differently, then what would be the right center and spread? Sorry, Monster Man, you gotta go. What would be the right center and spread if our data were to look more like this? What would be the accurate center and the accurate spread if our data looked more like this? Standard deviation and mean. Exactly. If it looks more normal, then the right center is the mean, which is right here at the center. And the right spread is going to be the IQR. Yeah. What happened there? The standard deviation. The standard deviation is a standard deviation away from the mean. So the mean is a proper measure of center, and the standard deviations are the right measures of spread. So you have to determine your correct shape before analyzing the others, because the other ones will determine the accurate measure of center and the accurate measure of spread. So the center and the spread are based on the correct measure of shape. Let's go back. Okay. So we could analyze something right here. I might go to a different data set because I did like doing different examples. Sure. Kentucky Derby data. Which was a class 2. I got winning time. Analyze distribution. To analyze a histogram in jump, analyze distribution will create the graphic of a histogram. Now you want to go here under Analyze Distribution and click the quantitative Y variable of interest, which we're going to pick for my examples of winning time. This definitely looks to have what's is. They are more than 1.5 IQRs above. We won't subset this data or break it apart. We'll just analyze as is. And I just clicked top arrow stack, and then second arrow, histogram options, count axis. You don't need the counts above the bar for this one because we don't usually do that on histograms. You can tell how much data is inside of here. It's a lot. It's like 110 observations or so. It actually, if you hover, it's 111. And we'll also do a nice light color. I like always my favorite color. There we go. And with this, what do you notice about the mean versus the median? What do you notice about the mean versus the median? What do you notice about the mean versus the median of this histogram? What do you notice about the mean versus the median of this histogram? What do you notice about it? It actually is a little bit of 320 right now. What do you notice about the mean versus the median? Oof. The mean is greater because the mean follows the skew. The mean will go in the direction of the skew. The mean follows the skew. So Monster Man's watching. He's watching the mean just go back there, back towards the skew. So the mean follows the skew. So if it's skewed to the right, the mean is higher than the median. If it's skewed to the left, the mean is lower than the median. The mean goes in the direction of the skew away from the median. The median is not impacted by skew or outliers because it's not the average. It's the 50th percentile, and it doesn't matter. Everyone knows. If a value is way higher, it won't pull up the median. It'll only change the mean or have impact on the mean. So because of this high skew nature, the mean is said to be unreliable. The standard deviation is also a metric calculated based on the mean. The formula is the sum of the squared observations and their distance from the mean over the sample size square rooted to find the standard deviation. And look what's in the formula for standard deviation. In the formula is the mean. That's sample mean right there. So if the mean's not reliable, and it's used to calculate standard deviation, Darius, do you see it? If the mean is not reliable, and then we use the mean to calculate standard deviations, then standard deviations would be what logically? Because it's in the formula. If it's in the formula and we shouldn't be using it, if we shouldn't use the mean, then we shouldn't use the standard deviation because it's calculated from the mean. So you go over here and you say, I'm not using any of that garbage anymore. I'm going to go over here and only use the quantile stuff because the quantiles are not impacted by outliers. This is a good hint for your assignment this semester. Due to the skew nature of the data, we will be using quantiles. So what does this mean? Remember, we are analyzing here. What is this? It's running time, the average time it took to win the Kentucky Derby. What does the 50th percentile mean? So due to the skew nature of the data, we are going to use, and don't copy exactly what I say. Good hints for semester. What does the 50th percentile mean? What does the 50th percentile mean? Anyone have any ideas what the 50th percentile means? It means 50% of horses. It is the center, but the median is 124. And it means 50% of the horses took longer than 124 and 50% of the horses took less than 124 because the median is the 50th percentile. The 50th percentile of horse race times was 124 seconds. Man, that's fast. The 50th percentile of horse times was 124 seconds, meaning that 50% of the horses took 124 or more and 50% of the horses took 124 or less seconds to complete the race. So what is the IQR? Well, the IQR stands for the interquartile range. How much data is contained in the IQR? How much data is contained in the IQR? It's the interquarters. To draw it out visually, it's quarters of data, and it's the inter ones. And quarters are worth 25 cents. So how much data is in the IQR? How much data? How much data is in there? And it's called the IQR. The IQR. How much data is in the IQR? What percent of the data set's in there? You can see it visually, and you can do it up there. How much of the data is in the IQR? How much of our horse race times is in the IQR? Not 75. Darius, good guess. Remember, it's the interquarters, which means it's two of them. So it's the interquarters, so it's 50% of the data because it's the inter ones, the middle two quarters, not the outer, but the inter. And so with it being the interquartile range, if I said calculate the range, you know the range formula like this. What's the range formula? Tell me the range formula. Someone said calculate the range of the data. You're like, I've done that my whole life. Brian, I could do range right here like that. I know the range formula. I know it. I've done it. What's the range formula? Max minus min. Big number minus small number. So just go crazy right now. Don't go too crazy. What do you think is the formula to calculate the IQR? What do you think is the formula to calculate the IQR? The formula to calculate the IQR is Q3 minus Q1. You just go here to Q3 minus Q1 because that's where the third quarter of the data is. This is after the third quarter, quarter one. That's technically quarter two. That's the min. That's the max, which is the range. It's just big number minus small number. So the IQR is going to be 6.5625. 6.5, 6.5, because you're subtracting these numbers. And if you can't do it or you forget, you can go here and get the IQR by going to Customize Summary Statistics and clicking Interquartile Range and clicking OK. You can also check for skewness if you want by clicking Skewness under Customize Summary Statistics, which is found right here. And we were just subtracting the Q3, which is 3/4, and Q1 right here. So how is this interpreted? The range of the middle 50% of horse races starts from 122.2 and goes up to 128.7625. This means the middle 50% of horse races have a range of 6.56 seconds. That's pretty small. Like, a lot of Kentucky Derby races take about 2 minutes, barely, just a little over 2 minutes. You can say to your friend, what if you told your friend, I bet the Kentucky Derby this year will last between 120 seconds to 130 seconds. You'd encompass a lot of the data. Now, there's a lot of outliers, but here's the thing. We live in the modern Kentucky Derby time, so you'd actually need to just take this data only, and you could look at this data only. Excuse me. And we're not required to do this for this assignment. I'm just wondering. We're going to do it to a different topic here. There we go. And so there it is. Still skewed. Still right skewed. And now the IQR here is actually smaller, 3.4, because there was like a whole bunch of other data. We just removed a bunch of data. What got impacted the most is going to be like the mean and standard deviation. If you notice with the removal of outliers, the mean and standard deviation are going to have the greatest change because those are most impacted. I think I deleted the old data set, or no, because I subset it. I have to bring the other one up. And there's the old data. The mean was 129, and now the mean is, can I get on? There we go, that's good enough. Standard deviation was 13, and now it's 3. The standard deviation decreased by 10. Yeah, Keely, you might have some time for that. Quiz 4. I have a little quiz 4. Drop some questions in for quiz 4. Let's hop to a new topic. Okay, that is the data analytics right there. We're going to do a little, the questions are Kaggle data for Mosaic. Okay. So 320 Kaggle data for Mosaic. BS 320. And Lance, bring up our studio. Pop my ears. Okay, if you're 320, listen in. There we go. Okay, so 320 is doing actually this week Mosaic plots and side-by-side box plots. I'm not even joking, but they're doing a little more advanced where we're doing more analysis on them. So if you're in 201, there's still some good stuff to hear. Question 2 on chapter 3, I'm still like, yeah, Brian, we got that coming up here. Is it the homework, Brian, or the quiz? Question 2, chapter 3. I think homework. Thank you, Brian. I got it next after these 2 sections. Thank you, Brian. Here's some points. Doing it soon. So, especially if you're 201, check it out. We're about to do some of your assignments. With this, what I want you to understand is you don't have to use Kaggle data. I'm going to show you some data sets here that will probably work. So get ready. We're going to load up library reg class. Now, if you're in 320 and you reg class doesn't load, what do you need to do? I'm just going to pause here for a second. A lot of people say, it didn't work. What do you do if that doesn't work? If that doesn't work, what do you do? If this doesn't work, what do you do? It says no package reg class. What do you do? Install packages, Dave right there. I'm gonna make Dave a mod right there. I trust that I'm gonna go out on a limb right here. You're right, Dave. You have to go down here. Someone's saying it didn't work. Install the packages, reg class. It has to be in quotes. It has to be exactly that and spelled correctly, correct capitalizations and everything. Okay, so mine works, mine loads. It looks scary, but it did load. It's just telling me a bunch of loading required packages and all that jazz. You may not know this, but you already have data inside of R. You got all these data sets here. You got Detroit Become Human right there. You got fires. You got Iowa in your data. You got all this stuff. You got McDonald's. Oh man, I love McDonald's. Pollution data set from McDonald's. What from McDonald? Oh, it's not Ronald McDonald. Okay. He's not polluting, I don't think. And you've got Titanic data. But if you go down here to the reg class package, you can see data sets right here. One of my favorite ones, I'm not suggesting everyone use this, but if you're stuck and nothing's working and you can't get Kaggle data, Survey 10, tried and true Survey 10. So how do we load up Survey 10? Data is a function that loads data that's from packages. You have to have the package loaded, and then you can run data, and then that file, that data name. So I run survey 10. Now I have data. Someone's like, wait a minute, that's how you can get data just like that? Yeah, if you have the package installed and you just say data, give me this data, and it says, there's your data. Now I got data. You don't even save it. It saves it for you. The data function loads data that is from packages. So chapter 4 quiz. Oh yeah, I'll do some of that. Kylie, that's a good one. So if I want to read in a CSV file, how would I do that? If I want to read in a CSV file, how would I do that? Like I have a comma separated value file. I want to read in a CSV file. How would I do that? Which we're not doing right now. I'm just showing you if you have a CSV file, you got to put it in your directory. You got to have it over in your files, read.csv. So you go there, read.csv, you put in the file name, a file name. Make sure to make it something other than file name, do it. And you might need strings as factors, true, not that. I don't know. There's so many options. Strings as factors, probably true. Do that. If you got an Excel file, you need library read Excel. Just take a wild guess at what read Excel does. It's a way to read Excel files. So now notice I have the read XLSX from read Excel package. There's actually another cool package that you can write Excel files. Guess what it's called? Write Excel. So now I have the write Excel function that if I take something right here and I go survey 10, actually you call the data frame like this, survey 10, and then you just go right here and you go mod data.xlsx, and now we blank the screen and you go over here and you tap mod data. There it is, right? That's CSV. Did I call another thing mod data? It's a CSV file? No way. I don't want that as a CSV. I want it as an Excel file. Well, my store it as a CSV file. Why would it do that to me? Well, it's stored. Sure. That's not the right data. Well, I don't know what happened. We're not writing Excel files today, so that's not the end of the world. I don't know where that went. Okay. So reading in files or loading files depends on what you're doing. If you have problems with this, let us know immediately. Post on the Discord, say my data's not loading in. So that's how we get our data into R. If you've downloaded data from Kaggle, you're going to have to read it in. Make sure the data has the right formats. Make sure it's in your working directory. All of these things are issues that I might have to address or look at and share screens on to see. So how in the world are we going to make some of these associate functions? So 201, listen in. This is where it gets really important for you. When the associate function runs, think of a C word. The what of the variable will be super important. When the associate function runs, and I do ask this, don't use any of the examples I use here because it's kind of hard to do when anyone can use any data. Just don't copy my examples. Don't make your assignment my assignment. Don't copy Brian. There's lots of other data sets. There's survey 10, there's survey 9, there's survey 11, there's the wine data, there's the football data, there's the attract M data, there's the attract F data. There's so many data sets for you to use. Survey 10's mine. What matters when we analyze data? It literally goes to the graphics we make in 201. What matters when we make data? What matters when we make data? What matters when we make data? It goes for 320 also. When we analyze data and we do graphics, what matters? What matters? The what? The way that variables are analyzed, like if we do frequencies or shape center spread, because think you do frequencies when a variable is what? 201 should know this. You do frequencies when a variable is this. You do shape center spread when a variable is this. You look at conditional and marginal distributions when a variable is this. You compare medians or 5-number summaries when a variable is this. I'll answer my own question in a second. The answer is the variable type or the class of variable right here. Factors are categorical into numeric quant. So you can see quant in or factor, categorical variable, quant. And then all the way at the top, gender being a categorical variable. Does that make sense, Ashley and Dave, right there? That the way this function runs and the way it uses the data is going to depend on the class or the variable type, the way it sees it. So if we go right here, and we haven't done this yet, both variables I'm entering in are what now? And I know it says num over there, but both variables I'm entering in are what? Both variables I'm entering, oh, that's read Excel. I was like, why am I not giving data? Both variables I'm entering in are what right now? Both variables I'm entering in are what? So both variables I've entered in here are what? Quant. So what kind of graphic am I logically going to get? I'm going to get a what? Logically, I'm going to get a what graphic? Great job, Jen. I'm going to add a dish or two. I'm going to get a what graphic, which we haven't covered yet. Logically, what kind of graphic am I getting? Logically, what kind of graphic? A scatter plot. There it is. I'm not going to go into the permutation procedure on this one real quick for the correlation permutation procedure, but that is the scatter plot, the visualization of two quantitative variables. Great job, Brooke, right there too. So we haven't covered this yet. So don't, if you get this, or if you get something like this right here, have you seen this? On a top graph, it looks like something we've seen, but this is a cat Y and a quant X, which a cat Y and a quant X is logistic. You see the cat Y right here, the Y is cat, and the quant, we don't do logistic regression to a 1. We will in 320 in like a month or two. So this is not something you want to get right here. If you're doing this, you're doing it wrong. So I need your help right here. Let's first do mosaic plots. For a mosaic plot, we need two categorical variables. So what should we analyze here? What should we analyze here for a mosaic plot? I need two categorical variables. So we're going to use the associate function to analyze two categorical variables, which we will get a mosaic plot. And you have to make sure you see factor for two categorical variables. Make sure you don't have a crazy amount of levels. If you see like 50 levels, talk to me and I'll help you get fewer levels. A really good amount is somewhere between 2 to 10. You also shouldn't have 1 because that's no variation in data. So what should we analyze right here? What should we analyze? I'm going to write a function while we talk about this. Gender and handedness. So we're going to do gender and handedness. So does someone's gender explain whether they're left, right, or ambidextrous when it comes to handedness? And if you get this, the figure did not create because it was too large for the window. We need to expand the window a little bit. And then we rerun the function right here as long as we have everything spelled correctly. And what do you notice? Take a look at this. Now it's a little bit bunched up. We could talk about making this, it's not horrible. That's a decent mosaic plot. What do you notice right here? Are these big differences for 201? Do these look like strong associations or not really a strong association? What do you think? Because we can look at the percent of males who are left-handed and it's 9.5%, and the percent of females who are left-handed is 8%. The percent of males who are ambidextrous, which is the little sliver right there, is 3.5, and females a little bit lower, but for both, it's 87% and 89%. These look like very small differences. The discrepancy is also very small. Now, this is not the F discrepancy. This is a chi-squared discrepancy, which tells us the differences between the observed minus the expected squared over expected. Check out the review video over that. And with this, what do you notice? The permutations are right here. Our observed discrepancy, is it like the permutations? Or is it very different? Our observed discrepancy, is it like the permutated results or is it very different? Just say like or different in the chat. Is this our observed discrepancy, which is that, the red line right there? That's the value of it. Is it like the random chance discrepancies created by the permutation procedure, or is it very different? If you're wondering, check out this. I think it's like, which means we think the differences here are likely by random chance. Let's do significant other with a typo in it. Take a look. This is a bigger difference with a lower p-value. Now, this is not the lowest p-value we've ever seen, but who's more likely to be in a relationship? Here's the males who are in a relationship, and here's the females who are in a relationship. You can see it over here visually with the females in a relationship being how far the red goes down here, the conditional distribution. And this is the marginal for everybody over here. The marginal is in the margins. The marginal is in the margin. And females are more likely to be in a relationship than male. And these differences look rather larger. And thus, what likely by random chance that we're seeing these differences? The differences right here between the conditional distributions, given someone is male, given someone is female, the probability of them being in a relationship look much larger, and what likely by random chance that these would occur. These differences look a lot larger, and what likely by random chance. And we could do one last one here too. They look a lot what likely by random chance. I would say they look way less likely by random chance because the p-value is lower. Wow. These graphics almost perfectly line up. What do you notice happened to the p-value since these differences are so very tiny for this last way of doing it? These almost perfectly line up. The p-value got a lot wider. Since it almost perfectly lines up, the p-value got a lot wider. Since it almost perfectly lines up, the p-value got a lot wider. If someone's like, you know, those people who have a significant other, they're more likely to be right-handed. What would you say to them? You'd say, yeah, okay, the data shows that they're more likely to be right-handed, but these differences that you're seeing between like 88.3 and 87.6 are probably just differences that are due to what? Like you'd be like, yeah. They're mathematically higher probability, but the differences are just so tiny. But these differences are just likely what? They're just likely by random chance. I don't think there's real differences here. I think all the differences you're seeing between this are just, you know, you collect a bunch of data and sometimes there's a little bit of differences. I always equate it, good to see you there, Young. I always equate it to the following. You run a race between your friends and you have a friend who beats you by 1 second. This is a marathon and your friend's gloating. Like you ran that race with your friend, you ran the marathon, and you're both really tired. You get to the end and they just sprint a little bit forward and they beat you by 1 second. And they're like, I'm better. Beat you by 1 second. What would you say to them? You'd say the differences in our race times are just due to what likely? It's likely that all these differences that you see in our race times are just what? What? Then you got a friend who beats you by an hour and you're like, that friend, that difference is what? That friend who beat us by an hour, that difference is not likely by random chance. That friend is better than us. Those differences seem to be real. They seem to be practically significant. Like beating someone in a marathon by an hour is a big deal. But beating someone in a marathon by a second is a difference that's likely by random chance, i.e. high p-value. We would not reject the null hypothesis that there's no difference between people if the null is that they have the same race time. So that is how to interpret the categorical or mosaic plot part. So what else do we have? We didn't just talk about mosaic plots this week. We also talked about what, which is a 201 topic. What else did we talk about? What else did we talk about? What else did we talk about? We didn't just talk about mosaic plots. We didn't just talk about mosaic plots. Side-by-side box plots. So side-by-side box plots require certain things. To do side-by-side box plots, you need a categorical X and a quantitative Y. So notice side-by-side box plots right here are categorical X, quantitative Y. And we did have a contingency table on that last one too. Great answers, David, right there. Dave, excuse me. Great answer. That is true. And that would apply to the last one, which you can see over here. And I do want to say this, please make your graphics look nice. I got to put a note in here in the notes for the second part of this, which is going to be 52.03 VAS 20 associate function side-by-side box plots. Okay. And sure. I'll do a making graphics pretty here. We teach stats here. Thank you for being here. Did ask stats question. We're working on stat stuff. Stat 201. That's what we do. So with this, if you simply just switch this right here and go to gender and weight, do you think these differences right here are likely by random chance? What would you say? The differences between gender and weight are likely by random chance or unlikely by random chance? You can see it. The average male weighs 180. The average female weighs 136. We're throwing off the decimals on that. And the median male, which means 50% of males weigh this or less, more or less, the 50th percentile is 175. The 50th percentile female weight is 130. We do math. Do those look like differences that are likely by random chance or not likely by random chance? And the answer is for are they likely by random chance right there. 0% likely by random chance via simulated p-value. And you can see it in the box plots. The more the box plots don't line up. Now, is this an easy bit of analysis to read right here? We got the permutation procedure, we got the normal probability plot, we got the histogram, we got this. Is that easy to read? And I do. And David, I bet you can get this. David, do you think we should analyze means or medians here? David, I bet you got this. Because I want you to look at this. For this data, do you think we should analyze means or medians? Statistical math. For this data, do you think we should analyze means or medians? Draw monster men here. What do you think we should analyze? Means or medians? What should we analyze? Means or medians? And why? Medians, because of the outliers, the skew nature of the data, the normal probability plot, right there. So medians, outliers, skewness on data. So medians, outliers, skewness on data. Everyone's always welcome here, and sometimes, yeah, we have a lot of visitors from all over the world, and I love it. And then sometimes stay a little bit on track. So with that right there, here's what we need to know. Because the data is skewed, as David's pointing out, we analyze the medians. So what should you do right here? If you're analyzing the medians, what would you say about males and females? What would you say about males and females? Any thoughts? Males typically, what? It doesn't mean all, because I weigh more than 175. I don't know, I'd like to weigh 175. Hashtag goals. Think about mathing it. Males typically weigh what? And this difference we see is 165 times bigger than what we would expect to be a random chance. Males typically weigh what? Doesn't mean all. Just what the data shows typically for the 50th percentile males versus the 50th percentile of females. What do we see right here? Males typically weigh 175, females typically weigh 130, and then take the difference of that. Males typically weigh 45 pounds more than females. Is that a big difference? Would you be like, imagine one day you wake up and you weigh 45 pounds more, 45 pounds of muscle. You wake up and you're like, it's like that Spider-Man moment where you're like, what's going on? Would that be a big difference? I'd say so. And so with this, we want to look at this difference and ask, is it statistically significant? Yes, the p-value is below 0.05. This is definitely a difference that's unlikely by random chance. That's what the p-value means. And then is it practically significant? Do I care about it? For the previous data, we would have to look at the differences in the conditional distributions seen back here to analyze the differences in the conditionals to ask if it's practically significant, which is the do I care about it. The last thing for 320 right here is making graphics beautiful. So please ask questions if you're stuck, because I just did a quick overview of these, but I want to talk about making graphics beautiful right here real quick for 320 and for all classes. So making beautiful graphics. Okay, where do you think I'm going to make beautiful graphics? Where in the world would Brian possibly go to make beautiful graphics? Always. You know right there, Dave, you know. Went in with ChatGPT right there, we got it. Here is my code below. Turn this into the most amazing side-by-side box plot, bot plot, using ggplot2. I need an A+ in the course because I currently have a -10. Give me encouragement after and life tips. I want to have prompts no one else has. I want it to be, here's your A+ worthy ggplot2 side-by-side box plot. This will ensure the visualization is clear, professional, and visually impressive. Life tips. A+ grades are great, but continuously learn and resilience will take you further in life than any course will ever. I disagree. A+ is a bit, I'm kidding. Keep showing, hashtag show up. Oh my gosh. Hashtag show up, that's, is it listening to me? I'm halfway afraid now. If you're in class today, so hashtag show up. We were literally talking about that in class today. So keep showing up, keep coding, and keep being awesome. You're not getting you're setting yourself up to win in the long run. So what is my favorite university course? It's freaky sometimes. Yeah. You know who I am. AI, they show up. I mean, it sees me right there. It knows who I am. I've had a lot of conversations with ChatGPT. Interesting world we live in. I don't give it extra things, but it can see the web. It can see everything on the web. There we go. Drop in. Run the code. It can see. Whoa. Okay. Problems. ChatGPT, this is almost good. What do you think? We can fix this. I would not turn this in. What do you think? Do you see what I see on what I don't like? Do you see what I see? Do you see it? What don't you like about it? We're making this graphic pretty and looks like this graphic went crazy. Do you know how easy it is to fix this graphic and make it look great? Think about where the color problem is, where there's too much craziness. This. Fixed. That easy. If you know what you're doing, you know what you're doing. It's like, ooh, let's take that off. And now we got a great graphic. It's even better yet. We can make this an interactive graphic, which you can't knit. I'm gonna call it plot one. Stored into plot one library, plotly, and then ggplotly. This can be an HTML graphic. You can turn in HTML files, so that's an option. And really, what's it ooh, it doesn't work in it. Unused argument. Over here. And make this work. I don't know why it's mad about that. You also incorporate unique themes like Mario Kart and sports to keep things interesting for students. And hey, if you're looking for more ways to make it look exciting, let me know. I've got plenty of ideas. You will not replace me, ChatGPT. You will not replace me. Let's say that nowadays. Error in computer not found. You might just send me the code, Dave. Why is it sending me that? Why is it giving me more life tips? I don't need life tips. This code won't work. Please fix it so I can make the plotly object. Probably send me what you have, Dave. Then we're gonna hop over and do a little more 201. It should be left arrow. Really? Oh, really? Let me look at it. Oh, yeah. Well, no, I could fix it. I can fix it. All right. Left arrow. Well, watch it not work. You can really make it work here with just a left arrow instead of a right arrow. Oh, look, it still doesn't work because that made no sense that it would just be the directionality by which I save. That doesn't make any sense. Oh, cool. Yeah. If so the attach function means you don't have to. Oh, GPA and computer are not found in survey. Oh, they are in survey 09? Yeah. And it says computer not found. Yeah, you might need to do it. Attach attaches the data frame. Let me go look at survey 09. Then we're gonna hop to a new topic. Survey 09 names of the vectors inside of it, and they have to be labeled this. So you probably need x24 computer. Your variable name has to be x24 computer. So Dave, I think that's it right there. And then GPA needs to be x11 GPA. It has to be the exact name that's inside the data frame, like identical to that. Does that make sense? So those, changing it to that, and if you do the attach, it has the autocomplete, so it can really help out. Awesome, good work. Make some cool graphics, and if you notice, it doesn't take but a moment, and then you hit a roadblock and it doesn't work, and you say whatever. Okay, homework 3, and we got quiz 3. Okay, we got 30 minutes. Let's go back to the main screen. Okay, I think we got 320 set up for success. And now let's go look at the homework. If you are here in your 201, what do you want us to do? It's your call. We got 30 more minutes about, maybe 25, 30 minutes. What do you want us to do if you are 201 and you are here? If you are 201 and you are here, what do you want us to do? We can do chapter 3 homework, chapter 4 quiz, chapter 3 quiz. Might do chapter 3 quiz because it's due tonight. Then we got time for chapter 4. Chapter 4, now we have done chapter 3 homework during office hours or something. Either one. I'm probably gonna do chapter 3 quiz because people might be watching this video for chapter 3 quiz. And Kylie, I'm probably gonna try to throw in a little chapter 4 for you. Thank you for being here the full time. Pick 2 questions, Kylie, and I'll maybe do them a little quick, and I can also get you some resources on those. But pick a question or 2, Kylie, that you're stuck on. But you did mention one already, right? What, Kylie? You've been here the whole time, and then David said either one, so you already mentioned one. Kylie, since you're here, remember this from the future for anyone who's watching this. If you're here, you get to pick. So that's what we do. Kylie already mentioned one. I'm gonna go find that question and work on that. I think it was the forest one or something, which is towards the end. I've done these a lot. Yeah. I think it's down here. I think you're wondering about one of these. One of those. Tell me the first 2 words of it. Thank you for this one, right? Is it this one, Kylie? I think it is. You can tell me if I'm wrong. Or whatever it says. Yep. This one's a tough one. Well, it's not tough. It's got parts. Okay. So then we'll do some chapter 3 quiz. Please let me know if you're stuck on a specific question. I will drop in that question and we'll do it. Stat 201, chapter 4 quiz. And this is the histogram summary, Parks, Vermont. Okay. Just looking at this, what kind of monster man we dealing with today? Keely, thank you, Keely, 1,000 points. Yeah, I'm really, thank you so much, Keely. Awesome, thank you, 1,000 points right there. What kind of monster man we dealing with today? What kind of monster man we did? Ooh, David, be careful here. What are we dealing with? There we go. Great job, Keely. Right skew monster man. We got a right skew monster man going on. So monster man, gotta give him his 2. Oh, gotta have it. Yeah, don't worry, it's just practice. We're here. You get that wrong answer out before the test. There you go, David. Some more points in the chat. So it is a right skewed monster man. Okay. So because the distribution is so skewed to the right, the what should be used for the center? So there's only 2 answers here. What should be used for the center? There's only 2 possible answers. So there's only 2 possible answers. The median. And then the spread would be the IQR respectively. Good review right there. How many parks are outliers? Now this is where it gets iffy. What we want to do is we want to figure out where the upper fence is. To figure out the upper fence, we need to first figure out the IQR. So the IQR is how much for this data set. How much is the IQR? What is the numerical quantity of the IQR? The IQR is how much? 50. All you're doing is just subtracting those numbers to figure out how far they are away. So what is 1.5 IQRs? 1.5 IQRs, because think it's 50, so 1.5 of 50, you get an extra 50% on your money, it'd be 75. Now what you need to do is add that to 78. So you'd go to 78 right here, where the 3rd quartile, or the Q3 is, and then you'd go up 75 to get to right about here. And this is where it gets confusing. So where are these data points? It's a little bit odd. And there's 1 data point here, 1 data point here, 1 data point here, and 2 data points here. So there's between how many to how many outliers right now? If you had to guesstimate, there's between possibly how many to how many outliers? Because I don't know if these go above or beyond the fence, which the data might go to there, or technically the whisker could go to here if they're both outliers, because the fence is somewhere around here. So there's between how many to how many outliers? 3 to 5 outliers. We don't know for certain. We could draw it out and figure it out, which we will eventually. So there are between 3 to 5 outliers, and their distance is the 1.5 IQRs, above Q3 or below Q1. There's not low outliers, because below 28, if you go 75 below, then it's not low outliers. So now we go and look at the data. A little tricky right here, but we got this. Okay, the median is 43. That could be, I'm trying to find, there's a few tells on these. Ooh, look at the Q1 right here. Q1 is 28. Does this look to be where 28 is at? Does everyone see what I'm looking at? Yes or no? Does that look to be 28 if you trace across? Because 28 is about a third the way up. Does that look to be 28? Like Q1 is the bottom of the box, which is 28. Is that where Q1 is at? Q1, right? Is that 28? Is that a third the way up? A little more than a third the way up this ladder? I'd say no. Good answer, David, right there. So what it is if you look right here, I'll make it very clear. Thank you for answering right there. Let me throw you some more points. It's Q1 is this, which is right here, which is about over here. And you'd have to say, is that where 28 would be at? And it's too low. It's not far enough up. The better views of this are going to be things where we go over here and we see that this is about where 28 would be at. That's about 28 if you think like a third the way up. Also, this one right here, which we can make these smaller, but these two are going to be our two candidates because that one, nope, that one's too low. So if you notice right there, so what differences do we see between these? Between these right here, I actually see a difference in this value. What value am I pointing at right here and right here? What value am I pointing at? This value is what? That value right there, that very specific value is what? It's 75 or close to, especially at a value close to 75, and it's Q3. Whatever value I'm pointing to is Q3. So which of these makes more logical sense? That this graphic right here is where, that's where 78 would be at. Do you think 78's right there? Is that where 78 would be on this scale? Is that where 78 would be? Or you got it, David. It looks to be this one because if you trace over here, it's a little bit above it. It's somewhere about there. It's right above it. It's a little bit above it, meaning that is probably the answer. A little bit tricky, tougher to do, but we got it. Write a few sentences describing the distribution. The distribution of the number of campsites in Vermont is unimodal. It's pretty unimodal. I don't think it's bimodal. Don't trick me. And it's skewed to the right. The distribution, the center of the distribution is going to be the median, which is 43.5, approximately 44. The distribution of campsites is, it's pretty spread out. I think so. It's very spread out, yeah. These parks have an excess of, and remember we calculated this earlier, it's going to be 153. That was the upper fence. I think we've done it all correctly. We have. This is the upper fence calculation we did earlier. I don't know if we still have the picture up. We don't. But that was 75 or 78 plus the 50 times 1.5 IQRs. Does that make sense? Little tricky problem. Good knowledge. The toughest one is maybe the quite spread out. Like subjective stuff is as tough as Keely. Does that make sense? How are we doing? That's one of the toughest ones on this assignment. We could do a question or two on the quiz for chapter 3. And I do have videos covering everything. You're welcome. It's a really good one. Like I know when people get to like the tough ones, the ones that people get stuck on. So those are the good, tough questions to work on. I got to bring my protein bars to campus. Got to be like, I need all the protein bars. It's like every meal has protein. Ugh. Fills you up though. Like, I got some Chris Bumstead protein, like a secret formula one. Like, just soup them. I don't know. See, if you eat the protein powder and you don't lift weights, you're fine, right? That's the way it works. Just protein powder, you good. Lift weights, don't need. Okay. Chapter 3 quiz. Life advice with Brian. Life advice with Brian. Do hinge exercises. Do carry exercises. Do hinge exercises. All that good stuff. Keep moving. At least, what do you mean rip? He's still around, right? Chris Bumstead's still around. Is it because he's not Mr. Olympia or he didn't win the Olympia or whatever? Scare me right there. Scare me right there. He's still around. He's doing well. I think he's doing well. Oh, he retired? Yeah, I mean, you have to. He's 30. You gotta. The level at which he's doing it is pretty insane. And I can't imagine doing. I mean, I think we all know competitive bodybuilding. It's an open thing that they're using performance enhancing drugs. It's a very, very open thing. So He's on something. Whatever, it's his personal choices. I choose differently. It's his life, his body, his family, is all his choices, and as long as he's well aware of the risks, which many of them are, I choose very differently, and I would advise friends and family and anyone I talk to choose differently if they ask my opinion. It's all my opinions, but that is his choice. But man, he got in some crazy shape. I don't know how they do it. What should we do? What question should we do here? David, which ones are you working on? Which questions are you working on? Which ones are you working on? If anyone has any questions right now. The rain, no rain, it's classic. I went to it and I stopped on it. It's a classic question. And when you get it, it's like, oh, I see how this works. It's the classic rain, no rain question. Okay, chapter 3 quiz. The rain, no rain question. Rain, no rain question. Okay. You first have to know what you're looking at with this question. With this question, we have a contingency table up here. What does actual mean? Like when you walk outside and it's actually raining, what does that mean? To say, no worries, David, we're going to get it right on this attempt. What does it mean to say it's actually raining? I mean, I know you're basically saying it. What does it mean to say it's actually raining? What does that mean? I mean, that means it's like it's raining. It's like you go outside and it's actually raining. It's actually raining. So how many days did it actually rain? Now, don't worry about answering their questions yet. Focus on mine. How many days did it actually rain? It's really raining, right? So how many days did it really rain? How many days did it really rain? And don't worry if you get it wrong, I'll show you how to get it right. How many days did it actually rain? How many days did it actually rain? You can tell me the math, or 35. How many days was rain forecasted? You can tell me the math if you want. How many days was rain forecasted? How many days was rain forecasted? How many days was rain forecasted? Not 29. 29 plus 64. So that's the forecast right there. So you would go across the row for the days rain was forecasted. So what happened on this day? Great job. Tell me about this day. You woke up and what happened? And then throughout the day, what happened? Explain to me this day on what actually happened. Just pretend you live out this day. There's 365 days in the year total. And this day is one of those days that happened. So what happened on that day? So there were 64 days on which this occurred during the year. What happened on one of those 64 days? Well, you woke up and you heard what? It's the forecast. You're like, it's gonna rain today. And you're like, okay. Gonna rain today. Gonna rain, got my umbrella. It's gonna rain. Start walking around campus and you're like, where's the rain? It's actually not raining today. They got the forecast wrong. What? It doesn't matter. Rock doesn't care. So with this, these are days where the forecast was incorrect. On the other one, the 6 days, it actually rained, but they said it wouldn't rain. The forecast was no rain. These are days where the forecast was correct. Because they said it would rain on 29 days, and it actually did rain. The forecast was rain, and it actually did rain. The other 266 days, they said it would not rain, and it actually did not rain. So we're going to use this information right here to help us solve the problem, because first it says, on what percent of days did it actually rain? So we just need to look and add up down here the following way, 35 total days it rained out of the 365 days in the year. We're just adding up this way. And once again, times this by 100, delete your decimals. That is 9.6%. I'm just going to do it in my head and not get it wrong. On what percent of the days was rain predicted? That means we go across here to do rain predicted, 29 and 64. double check your math. It is 93, I believe. And we add up 2964 and divide by 365, which is the total days in the year if you add these all up. It's not a leap year, apparently, and it's 25.5. To find out when the forecast is correct, what numbers would we add together? Great job, David, right there. So the percent of time the forecast was correct is what two numbers added up right here. The percent of time the forecast is correct is what two numbers added up. The percent of time the forecast is correct. Because they'd have to say it rained, or it's going to rain, and then it would have to actually rain. They'd have to say it's not going to rain, and it's actually not going to rain. So what percent of time was the forecast correct? How would we figure that out? You got it right there, David. And then we divide by the total. So David's done it. We do the times when it's correct, 29 plus 266. Divide by 365. And there's the answer right there, 80.8. 80.8. This one's a bit weird the way they did it. It reads, given the forecast, given it rained, the forecast was correct. So you have to look at it this way. Given it rained. So given it actually rained. Ready? To show given it rained, we are only going to look at this. Given it rained, the forecast was correct. So what would be the math here for given that it rained, the forecast was correct? And I'll highlight something which gives it away in a moment. Don't worry about being wrong. What is the math for when it rained, when it actually rained, the forecast was correct? So think of a percent right here. What percent of the time when it rained, the forecast was correct? What would you do? So you have to think of all the times it rained and then when the forecast was correct out of that. You got it. That's it. Yep. And when you do this, that's what this says right here. Given it rained, the forecast was correct. It's written so weirdly, and they try to explain it, but it's easier if I just say it. You really just take 29 divided by 35, and you literally get the 82.9 when rounded. And if you do the other ones, given it rained, the forecast was incorrect, you can do the other ones, but it's that answer right there, which gives it away. The last thing right here is, do you see an association? Well, when it rains, they're right 83% of the time, and when it doesn't rain, they're right 81% of the time. Do these differences look small or large? So this goes back to the mosaic plot idea that we were just doing with 320 a moment ago, where these are big differences. Although this is a large difference right here. That's a big difference. We go back to some of our other graphics right here. That's a tiny little difference. Do these differences right here between that one and that one and that one and that one, do they look large? Like that looks large. I would say these differences are very small, leading to us believe there is no evidence of an association right there. They do not look like big differences. The differences look likely by random chance. So really, whether it rains or not, the forecast has about a 81% accuracy. It's small differences that are likely by random chance. We have time for like one more. Do you have one more, David? We got enough time. The meeting starts in 12 minutes. You don't? Oh, you said no for earlier. I have no more questions. I'm done. Man, I got less sleep last night. I got like 6 hours. I was like not gonna work out, and then I was like, I gotta. There was one night I fell asleep in front of the TV. What was the question? Do you have any more questions? We could do one more. We've done a lot, and they're very available. I fell asleep in front of the TV one night, like I woke up, so it was like 10 p.m. at night, and I fall asleep. And I usually work out at like 11:30. Maybe it's like a horrible idea. I don't know. How many quiz grades get dropped in this group? One quiz grade. Medical researcher. Let's do medical researcher. Then I woke up and I was like, I gotta work out. I remember the first few like lifting of the weights. I was doing like a row or something, and I was like, I don't want to do this. I didn't want to sleep. I did it. Let's do medical researcher. And then I like went to bed and was like out like a light. So, and then I skipped leg day because no one does leg day. Don't skip leg day. Chapter 3 quiz, medical researchers. This is about a placebo pill or a non-placebo pill. And a placebo, we do Swedish men too one. Oh, okay, we'll do this is the placebo one. Okay, we'll do this one real quick, and then we'll do Swedish men. You got it next. Here we go. Okay, for this one with the placebo question, a placebo is basically a sugar pill. It's not a real drug. The problem is with this one, you have to watch out because the answer is not always the same. I'm going to get a different answer than some people, so watch out solving this. I've had people say, I put the answers you put, and it didn't give me the right answer. It's because these can drastically change. Yeah, Keely right there. We've done a lot of them, you're right. And so with this, how would we figure out the relapse rate for the antidepressant drug? How would we figure out the relapse rate? Thank you, Keely, right there, for giving that advice. What percent of people took the antidepressant and what percent of those people relapsed? Well, like how many people, I should say, took the antidepressant? And then out of those people, how many relapsed? So how many people took the antidepressant and then how many of them relapsed? I might answer it. The answer is, with the antidepressant, 5 out of 48 relapsed, 10.4%. And the relapse rate on the antidepressant was 10.4%. And then over here, we have 14 relapse out of the 52, and that's 26.9%. And that looks like a big difference because it's a difference of like 16, 17%. I'd say there is evidence of an association. If the two values are a lot closer, we do not have evidence of association. That one's long root on that one. These are annoying questions. They can just take a while to calculate things. Oh, we did that one too. Swedish fish. Here we go. Medical researchers, Swedish men with prostate cancer. Okay. Okay, for this data set right here, the first question is asking about marginal distributions. Now there's two variables, and they didn't plot the second margin, but you can see the margin down here for whether or not people had prostate cancer. And think of a W word, the width of a bar determines the percentages for each of these variables. The width of the bar, the width of the bar, a W word we're looking for right now for some points from Ubot. The width of the bar, the width of the bar. The width of the bar determines the marginal distribution. So about what percent of the width is the small one right here? You think of a percentage out of 100% from 0 to 100%. Now watch out, I know the 100% goes up there, but what percent of the men got prostate cancer because you can view it this way? So what would you say the width of that is? Like what percentage of the data? Like it goes through what percent? And remember, this is a smaller one. That's about what percent? Yeah, 10. If you watch the previous videos, people said 5. This question's very lenient on the answers. 10 should work. It's a guesstimate. It's a guesstimate. It's very, very lenient on answers. Pretty much any reasonable answer is accepted. Just don't go crazy. But you're seeing answers here. This one right here is a little tough, and you have to know what they're asking. What they're asking is they're asking about the amount of people in a group. They're asking, is there more data inside of this? I'm going to do it in an orange. That sliver there, or this sliver there. Does the no group have more data in it, or the yes group? And the data, the amount of data, is the area of the rectangle. Like how many observations there are is the area of the rectangle. So if I told you can have bar of gold 1 or bar of gold 2, which bar of gold would you take? Bar of gold 1, not A or B. Correct. Bar 2 is a little bit wider. Bar 1 is way longer. So it's like way more data inside of bar 1. And the amount of area it takes up encompasses the amount of observations within it. As think of it as like a pizza. So I'd say I'm going to give you slice 1 or slice 2. You say, I take slice 1 because I want more pizza. I don't care about how tall the pizza is. I want that, I think that long, I was a breadstick. These are breadsticks. So I'm just hungry for lunch. So it would be the no group, those who did not have cancer, have more observations in there. But the second question right here is not asking about the amount of data. It's asking about the percentage of the data. So now we're actually looking at the conditional distributions. So the percentage of the data is going to be matter or observed right here based on the height of the bar. So within the yes group, there is a greater percentage. Does that make sense right there? Because If we were to expand this, you would see the 1 bar looks like this, group 2 looks like this, and group 1 looks like this right there. And it might be about half the size rather. And it would be way longer, but we're only looking at this right here when we look at the percentage. And that's just an expanded view of it, like if we were to zoom in on it. I mean, why not? Why not? We're here. Why are we here? Just to suffer. Too many video games. That's what we're here for. You can see it there very clearly now. You can see the percentage within the group is higher, which is the conditional distribution. Given a man had prostate cancer, the percent of time they never seldom ate fish is higher, versus given a man did not have prostate cancer, the percent of time they never seldom ate fish is lower. These differences are likely by random chance, and they're small, but they want you to observe them nonetheless. So that's got it. David, does that make more sense right there? The first one is dealing with the total area to figure out how many observations are in the groups. And you're just seeing which one seems to be a bigger area. There's also one on the college presidents, which they're hard to tell. It'll be like the answer's hard to tell on that one. And then ask the same percentage one, like which one has a greater percentage within, and that would be the heights of the bars, the proportions. And yeah, so good stuff. Well, we did a lot today. Very happy. All stars yesterday was so slow, which is fine, but I like when we're just rocking out and doing some work. Till then, bye for now, everyone. Bye!
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!